Welcome to our very last module we're going to look at in chemistry, and this has to do with neutralization. So this is section 7.5, I think, in the textbook, and basically it's just the concept of take an acid, add it to a base, and what happens to those ions is that they turn into water because you have the hydrogen ion from your acid, your hydroxide ion from your base. They come together and make H2O. Water, which is neutral, and they also make a salt. Okay, so that is the standard characteristic formula for an acid-base reaction. So you predict hydrochloric acid, sodium hydroxide makes sodium chloride, that's your salt, and water. Okay, can you see that? So that is your general formula for acid plus a base, and that is what is called an ionic compound for your salt, and that overall is a neutralization reaction. There's a few different neutralization reactions, and the textbook goes over like a chemical spill, what would we do, and antacids is the next one. Okay, so I want to go over just two basic demos with you. We're going to do the one that we did in Tuesday's module, where I'm just going to add the acid and the base together, and you can see the indicator change by the phenolphthalein. You can see that it's turning one way or the other, and then of course when they go together they make a neutral solution. Then the next one is going to be looking at the antacids, okay? And so for the antacids, I'm going to take this substance here called milk of magnesia, and we're going to look to see how it changes as I add an acid to it, because the milk of magnesia is a base. All right, so that's it for this part here. So let's have a look at the note. So you can see that a neutralization reaction is specifically one where you've got your acid dissociated in water and your base is dissociated in water, and what's going to happen, those hydrogen ions come together with the hydroxide ions and make H2O. Okay, that is your typical characteristic of the neutralization reaction, and then there are a few questions you can do with that. So let me make this video a little bit bigger, and I'll show you what we're going to do with our acids and our bases. So for the first one right here, I have a stir bar, which is a magnet bar in a beaker, and in the beaker here is a little bit of acid, okay, and it's colorless right now. I haven't added any indicator to it. If I turn the magnet stir on at the bottom, okay, I can end up with, the magnet will go around. Let me just add a little bit more acid here. Okay, as I've got some acid and it's stirring around on my stir plate, I'm going to add that phenolphthalein indicator to it. Do you remember if I add the phenolphthalein indicator to my acid, it's going to be colorless. Okay, so no change in color there. And then as I add my base, you can see what's going to happen. Nothing at first, as my hydrogen ions react and become neutralized with the hydroxide ions that I'm adding in. At the point where I reach that neutralization point and I have more hydroxides than hydrogen ions, it's going to then read as being a base. I guess I could put this in a little faster, couldn't I? I'll do that with the next one. I'll just keep adding it in, and you can see that eventually it will turn pink when I have more of my base. So as I add it in, you'll notice that it becomes pink right there. That's your hydroxide ions reacting with your phenolphthalein, and as I end up with a neutralization reaction, you can see that because the hydrogen ions bond to the hydroxide ions and water gets formed. All of a sudden, you can drop in very small amounts, and it will go all of a sudden completely colorless to all of a sudden completely fuchsia. And we're getting very close to what we call the end point, and now we've gone over it a little bit. This is an indicator right here that now I have more base than acid because it's a little bit pink. And look at that, some of them still reacting with your water. Let's add a little bit more. And as they are forming, I still have a little bit more hydroxide than hydrogen ions, and that's why I indicate it as being a little bit basic. Okay, now for the next one, what we're going to do is we're going to add, I'm just going to dump out my solution, which was mostly basic right now, and I'm going to add to it the milk of magnesia. Okay, so what I'm going to do is let me just turn the magnet off, and I'm going to start by adding my acid again. Okay, here now I've got loads of acid, and I'm going to add in my universal indicator. Okay, remember it was green. What color does it turn when I add it to an acid? Do you remember? Red. Okay, let's add a little bit more. Okay, now I'm going to turn on my stir bar. As I turn the magnet on, it's just helping to stir it without me having to take anything and move it around, okay? So you can see right there. Now, if you have stomach problems, if you're eating, and you actually end up with a stomach pain, right, because you've eaten something too spicy, then what you want to do is you want to be able to neutralize that stomach acid, because you get acid reflux when the acid pushes up into your esophagus and it feels that burning pain. If you've never had it before, ask somebody who has. What you can do is you can take some milk of magnesia. So this is a substance right here that I'm going to just use my bet for, because I'm only using it for this. I'm going to add in some base to my solution, and the more you add in, the more you're neutralizing your stomach. So I'm going to keep adding this in a little bit, and this is my base now being added to my acid, and it's going to start to change color. Maybe let's go a little bit faster. And all of a sudden it turns in the basic range. Okay, can you see that? It's now blue. That indicates, because of the indicator in there, that now it's more basic than acidic. So what happens if now I decide to add a little bit more acid? It's going to push it back towards the acid range. So here I go. And now I've got more acid than base. So what do? Let's add a little bit more base. And again, this is my, oh, you can see it's already, as the time it mixed, sometimes it changes color and then all of a sudden it keeps adding to it. So let's keep going back. We'll add a bit more. And as it's starting to work, look at that. It's dissolving more as we go, as I'm adding more water at the same time I'm adding more acid. There's a lot in there. I'm pushing it towards the acid, and then all of a sudden it's pushing it back towards the base. Let me keep adding a little bit more acid. Hopefully I can make it go back to the pink. This is an interesting concept of kind of like buffering a solution, where I'm pushing one way towards the acid range, and then that base, as it's dissolving, is pushing it towards the base. And I can add a bit more acid, pushes it towards the acid, and then as that milk of magnesia is reacting, it'll push it a little bit more towards the base. Right now I'm pretty neutral, and then all of a sudden now it's starting to indicate that it's more base. So this is a really fun little demo that we can do, where we're mixing acids and bases together and we're doing a neutralization reaction. And that is it for our lessons on acids and bases.